Okay, so now we are going to get into some compound interest problems, right? And now, when we're talking about compound interest, this is a situation where basically you have an amount of money, and it has interest applied to it, and then once the interest is applied to it, so interest is money that an institution pays you for basically investing in something or putting your money in something. And then when it compounds, that means that they apply that interest to your amount, your initial amount that you put in. And then the next time there's interest compounded, it's not only done on the amount that you initially put in, but now it includes that interest that went in. So every time interest is getting made, it's being made on more money, right? So it really adds up, and it grows exponentially. And it doesn't start out really fast at first, but it can really get big over time, right? Which is why the investments that do well are the ones that that do have compounding interest and stuff like that. And they usually, to be honest, they usually cap it over a certain period of time, because otherwise they just the institutions will lose money, right, doing that. But that's kind of how compounding interest works, all right? And so in this problem, right, so the first thing I want to talk about before I start talking about the problem is this is the formula you use, all right? And so it looks very similar to our exponential formula, which was y equals a times b to the x, right? Except this time it's sort of like our exponential decay and growth ones, where you've got r, but r is now going over this n thing, right? So the rate's over the number of compounding periods per year, and your t, which is your x, right, is multiplied by the number of compounding periods per year, right? So that's so we're just going to basically use this formula. We're going to plug and chug. We're going to put stuff in, and we're going to see kind of what happens as a result, all right? So an investment account pays 4.2 annual interest, all right? So this is going to be our rate, right? So that's going to be R. Monthly. So monthly, all right, n is the number of compounding periods per year. So if it's monthly, that means that there's 12 of them, because there's 12 months per year, right? And then 2,500 is going to be our principal amount, right? And that's basically your initial amount, right? Initial amount. 2,500 is invested in this account. What will be the balance after 15 years? And then 15 years is going to be our T, all right? So the way we would figure this out is we would say A, all right, is equal to P. Well, my principal is 2,500. And then you are multiplying it by this 1 plus, well, my R is 4.2 divided by 12, okay, because N is 12, right? And then it's 12 times T, which is 15. So you got 15 times 12. Well, 15 times 10 is 150, and then 15 times 2 is 30, so it's 180. So it's to the 180th power. All right, so if we simplify this, we have 2,500. So 1 plus 4. So let's figure out that middle part here. So I got my calculator busted out. So I'm going to do 4.2 divided by 12, and that's going to give me 0.35. I'm going to add that to 1. So my middle number is 1.35, right? It's a pretty good number, to be completely honest with you, right? Oh, you know what I did wrong? And nobody corrected me, right? Is my rate, I have to, no wonder it was a good number, because I was doing it incorrectly. With your rate, when you put that over your decimal, over your 12, right? The 12 was right, but here's the problem, is it's not 4.2, it's 0.042. Now, we're going to get something very different. So 0.42 divided by 12, yeah, there we go, plus 1. All right, so my number here in the middle, and it looks like it's not very big, and that's what kind of clued me into this, right? It looks like it's not very large, but watch what happens, all right? So we got this number, we've got this 1.0035, and we're going to raise it to the 180th power, right? And it's not a giant amount of money, right? But it's 1.875546, right? So about 1.9, not quite. But if I multiply it by 2,500, right, that means that at the end of 15 years of doing nothing with it, right, you have $4,688 and 80, and we're going to round this up, 87 cents. And that's your balance, right? Just for putting money in. So you made, you made basically over $2,000 just for dumping money in. And the thing is, when you invest more, you're going to make more because you're multiplying, even a very small number times a very large number. It's going to make a difference, right? So $4,688.87. Okay, let's take a look now at one more example. So it says find the account balance after 20 years if $100 is placed in an account that pays 1.2% interested compounded twice a month, right? So that means that in the span of a year, right? In the span of a year, this happens 24 times, right? If it's compounded twice a month and there's 12 months, that's 2 times 12. That gives you 24, right? And this is our T is 20. This is my P. All right, so we have A equals P times 1 plus R over N to the NT power. All right, so let's plug our numbers in. So we have $100. All right, let's see what $100 can do. 1 plus, and my rate is 0.012. Good, Mr. Simons didn't make the same dumb mistake. All right, over 24. So this is going to be a very, very small number, right? And to be fair, 1.2% is not much, right? But this N times T is going to be interesting because we have 20 years and 24, so we basically have 20 times 24 up here for my N times T, or T times N. Multiplication is commutative, so we're cool with that. So my exponent is going to be 480, right? So we're going to have 100 times whatever our number is going to be over 480. And now let's figure out what our number in the middle is going to be. So I'm going to go 0.012 divided by 24 gives me 0.00. So it's 5/10,000ths, right? So this is a really, really small number, right? It seems almost negligible, like it doesn't do much, right? And let's see what it actually does over 20 years, even with just $100, right? Which is not a lot of money to invest. All right, so that gives you 1.27 something. You multiply it by $100, and then over 20 years, just by virtue of doing that, right, your investment became $127.12, right? So you made a 27% gain in that just by leaving it, even though it says 1.2%. The fact that it's compounded twice a month is a big deal, right? And believe it or not, those are very competitive accounts to try to get your money into. So this is kind of interesting stuff. Compounding interest can really work for you for investments, and it can really work against you the same way for like credit cards and things like that, right? So yeah, this is interesting stuff. So hope this made sense, and have fun solving these.